Stefano Bourcheid, who will be talking with us. And he's a software engineering leader at GLS, and they're an international parcel delivery service, primarily in Europe and North America. And their internal innovation lab is aimed at modernizing the process, delivering packages through new innovative technologies. And Stefano co-founded the studio and built the next generation of data-driven products. So he's going to share with us a bit on optimizing parcel delivery routes, which is fascinating. It's always routing is such a fascinating topic, and always computationally challenging as well. So really look forward to hearing what you have to say on this, Stefano.
Awesome. Thanks a lot, Sean. Thanks for the intro. Hello, everyone from LinkedIn. Plino, I guess you can also bring up my screen on stage. I think it's already there. Thank you very much. All right. So hello, everyone. Stefano Bourcheid here. Yes, technical co-founder of GLS Studio. As Sean said, we are an innovation hub inside the GLS group. So we deal with the parcel delivery business. And I'm excited to talk about how one of our pilot products called Parcel Planner uses Fused currently. So let's jump right in. First of all, Parcel Planner is basically a software to support our transport partners on their daily tour planning with balanced tours and better data and easy dispatching, right? So historically, zip codes are used to do the routing, right? At least the big routing, but sometimes even the fine routing. Zip codes vary a lot by country, and they are normally very old. Here in Germany, we do have very, very big zip codes, either in territory or in population density, which is not very helpful. So, sometimes one driver cannot even deliver to a whole zip code, right? What is normally done is that we kind of, it's lagging a bit, my audio. It's understandable though. Sorry. So, okay, good. So splitting the zip codes is a normal approach, which you can basically make this Lego blocks a bit smaller, but they pose their own challenges, and that's how it's been traditionally made. So, and if you look at reality, this is one single delivery day in the Geneva airport, and each single color is one different driver. So you can see that drivers still go all around each other, kind of sharing an area, which is of course kind of wasteful in terms of resources, right? You want to drive the same area every day, so you're pretty much an expert to it, and you don't want to be crossing with others too much, right? So this is Parcel Planner. We love H3. We don't really want to maintain our single proprietary cells, which we call fine cells, right? Splitting up zip codes, because then population density changes. You have to keep and maintain those breaking down zip codes. That's why we love H3. H3 offers us a normalized way to store data, to compute data, and we can control the precision versus the compute, right? If you have to be more precise, we can turn up the precision and be a bit more accurate at the expense of more computational cost, right? Now, this what you see here is basically an H3 heat map of the predicted delivery parcels that are coming in for tomorrow. So we have a machine learning algorithm that kind of tries to figure out which parcels are going to come for tomorrow, and the areas are basically your tours, right? So conceptually, this is pretty simple, right? In the front end, we do use Honeycomb maps, which is also a startup. Shout out to Honeycomb, shout out to Carson. Honeycomb is using DuckDB WASM on the front end, and it basically needs to connect to a Parquet file, right, somewhere, and we use Snowflake. This should be simple enough, right? Well, in reality, this couldn't be further more for the truth, because the end user, the front end, is as far as it gets for the data warehouse, right? So in a normal, if you want to build this story by the book, you would have to have a backend API that would then process through its own kind of product DB, which would then be fed by an ETL job, which would then be fetching the data from your data warehouse and kind of cloning. So you have a lot of data redundancy and a lot of infrastructure, which is not what we want to build from the get-go once we want to test out a feature, right? Fused offered us a helping hand in terms of it kind of gets rid of a lot of this middle ground, right? So Fused act as the backend API, as the product database with its cache, and as ETL jobs, because you can just run Python code and grab your data, right? So it simplified a lot of that process for us. So yeah, it looks much better architecturally. A little bit more detailed here. So again, for the client, we have DuckDB wasm, which is then fetching data from Fused. So I have a single UDF to act as like the receiver UDF, which is like public facing, so to speak. This UDF handles things as authentication. It's not really cached. And what this UDF does is kind of like fans out many nail UDFs, which run in parallel. And those nail UDF workers kind of try to grab the Snowflake data that we need through SQL, right? So what they need to be of note here is, of course, you can DDoS your own data warehouse if you want, because you can spin up 1,000 machines in parallel if used. But that, of course, depends on your data warehouse, your configuration, and your tolerance to risk, right? So now a little bit more in detail how this works. Hopefully this is high resolution enough. Otherwise, maybe I can make my screen a little bit smaller. Hope this helps. Not quite. Okay, good. So this is the UDF code. So the first, it's very simple, right? It is very simple code. The first box handles the cache. So this run fused basically calls our nail UDF, which is then cached. So given the same input parameters, it doesn't call the nail UDF at all. It just returns the cache. So we pass like a single date, the subco ID, which is like the user ID, a seed parameter, which I'm going to come to next, which environment we're querying. So this simple decorator here handles the caching for us, which prevents us from spending many, many thousands of dollars extra on Snowflake requests, because the end users kind of click around at this map a lot, right? Now, the other interesting piece is the cache validation logic. So since we're querying per day and the users can see the future, we don't want to cache the future or today, because today there's still data coming in and tomorrow there's more data coming in. So what we do is basically everything in the past is permanently cached, so to speak, and everything from tomorrow on is cached by some time, right? So here's where we control. You can see simply, 6 lines of code here. We have a seed parameter, which is stable. And then if you're looking at the date, which is equal or bigger than today, we basically kind of seal the current hour on the clock, basically divided by 2. So it's basically creating like a cache for the next 30 minutes, or like 30 minutes on the clock, right? And then the seed is stable, at least for or at max for the next 30 minutes. So that's a pretty neat solution. It works quite well for us. And it kind of handles the monkey tapping around versus, when does this thing update, right? And you can easily control here, what's your TTL, so to speak. And last but not least, we do have the code to run all of the parallel Neo UDF calls, right? It's as simple as this. We just have a thread pool executor, which would then call, up to 100 workers, and all in parallel. So again, we just have to be cognizant of the DOS in your own data warehouse. Fortunately, Snowflake is quite resilient to that, and it just, it's a matter of configuration and cost. So yeah, and you can see that actually getting, I would say, if we were to just query our Snowflake as it currently is, every single day would take up to 10 seconds because it's a data warehouse. We have a lot of stuff there. And Fuse reduces this to less than 1 second per day, which is quite an improvement already. So yeah, and I guess another thing that we can maybe talk about in the next time is how to warm up this cache so the user doesn't have to hit this like 10 seconds load time the first time he loads the app at all. So yeah, well, that's about it. Thank you very
Great.
much.
Thank you. That was fascinating and wonderful. It's really cool to see the kind of under the hood, how such a large, complex operation of deliveries happens on a day-to-day basis.